Yo, what's up everyone? Welcome back, Patrick here, and in this video what we're going to do is simplify a couple of unique expressions that we haven't covered yet. The same rules are going to apply, the same general rules, it's just the way we go about them sometimes is going to be a little bit different with these. Notice that these are in a pretty unique format that we haven't seen yet. So starting with number one, we got 3 plus 4 over x divided by 3 minus 4 over x. So what do we usually look for first? We look for, can we factor anything? And notice in this case, there's nothing to factor. We got this 3 plus 4 over x, 3 minus 4 over x. Can't really do anything with that. And then what we want to do is we want to get the restrictions. Now from here, with this particular expression, the restrictions are going to be a little bit unique to get. Notice that we can tell x cannot be 0. Right? That's a restriction. That is pretty obvious because it would make this denominator 0, make this denominator 0, and you can't divide by 0. But there's also another restriction in this case that is a little bit more subtle, a little bit more tricky to see. Notice what we're doing is we're taking an expression up here and then we're dividing it by another expression. And as I mentioned, you can't divide by 0. So that's why this x can't be 0. You can't divide by 0, you can't divide by 0. Well, notice that this whole expression can't be 0 either because we're dividing over here. And then if this is 0, then it's going to be undefined. So not only can x not equal 0, but basically this whole denominator, this 3 minus 4 over x, cannot equal 0 either. And that's what's a little bit tricky about this particular expression, is getting that other restriction. Now, actually getting this other restriction, there's an easier way to see it, and we're going to see it after we simplify a little bit. But if you want to get it right away, this is how you get it, right? So 3 minus 4 over x cannot equal 0. And so what we got to do is isolate for the x. So basically 3 cannot equal 4 over x. We can cross multiply, so 3x cannot equal 4, which means x cannot equal 4 over 3. So those are the two restrictions for this. Now the way we simplify this is we actually want to take both of these expressions and combine them into one fraction. So this 3 plus 4 over x I'm going to deal with over here. Notice this 3 is like over 1. If we were to combine this into one fraction and get a lowest common denominator, we would multiply this by x, multiply the top by x, so we would end up with 3x plus 4 over x. Right? So 3 plus 4 over x is actually the same as 3x plus 4 over x. This and this are the exact same thing. And then if we apply that same thing over here, this 3 is like over 1, lowest common denominator is x. Multiply the top by x, so we would have 3x minus 4 over x. So this bracket and that original bracket are the exact same thing. And see, here is where it's easier to see that second restriction, because this, we can actually rewrite this as 3x plus 4 divided by this 3x minus 4 over x. And then it becomes exactly the same format as we've dealt with in previous examples. So notice from here, we can get these restrictions a lot easier. X can't be 0. And then remember, if we're dividing, we get the restriction from that numerator as well. And then over here, 3x minus 4 cannot equal 0, which means x would not equal 4 over 3 if we isolate for the x. Same restriction that we got before, right? So that's an easier way to go about it, to get the restriction. It's a little bit more obvious, but you got to do a little bit of simplifying to get it into this format. And then from here, same stuff applies. So basically we'll have 3x plus 4 over x. We would flip this, change it to multiplication. Notice the x's cancel out. And so we end up having 3x plus 4 over 3x minus 4. That's the final answer. That's the final simplified expression for number 1. So that's the final answer, and then those are the two restrictions. right? So pretty unique one. Number 2 is also really unique. Now you may not be working with radicals within rational expressions. So if you're not, maybe this example is not going to be as important. But just in case you run into something like this, thought I would include it. So first thing, notice that this here is going to be over 1. So what we're going to do is we're going to take these two and then combine it into one fraction. Now in this case, can't really factor anything. Notice the 5 over 15, that's going to simplify, but remember the steps: factor, restrictions, then simplify. So notice we can't factor anything. What are the restrictions going to be? Well, notice that this denominator here, this 1, that's never going to be 0, so there's no restriction over here. And then notice here, this is never going to be 0 either, because 15 is never going to be 0. And then notice that no matter what x value we plug in here, whether we plug in an x value of 0 or we plug in a negative x value all the way to negative infinity, all the way to positive infinity, we're always going to be square rooting 5 or a number greater than 5, because this x squared is going to end up being 0 or positive, right? X squared is always going to be greater than or equal to 0. And so this whole term under the radical is going to be, that means x squared plus 5 is going to be greater than or equal to 5. The square root of 5 is going to give us a positive number. Positive times positive, it's always going to be a positive number. So basically, this denominator can never be 0. All right, so there's no restriction. In this case, there's no restrictions for this expression here. Now, if we were to simplify it, as I said, the 5 over 15, this would be 1 over 3. So we would end up, let's rewrite this, we'll have x squared over 3 root x squared plus 5 minus root x squared plus 5 over 1. Now, to combine these into one fraction, what we're going to have to do is, what's the lowest common denominator between this and this expression? It's going to be this expression, so we're going to have to multiply this by 3 root x squared plus 5. And then the top, we're going to have to multiply by 3 root x squared plus 5, like that. And then what happens, notice that root x squared plus 5 times root x squared plus 5, that's just going to be x squared plus 5. So all of this is going to simplify to x squared minus the 3 is going to be in front, and then root x squared plus 5 times root x squared plus 5 is just x squared plus 5. And this is going to be all over 3 root x squared plus 5, like that. And then we just have to simplify that numerator. So if we distribute, we'll end up with negative 3x squared. We'll have, actually, yeah, let's write it all out. X squared minus 3x squared minus 15 all over 3 root x squared plus 5, like that. And so from here, x squared minus 3x squared gives us negative 2x squared minus 15 over 3 root x squared plus 5. Then you want to see, does this factor? And notice we can't really take anything out. We could take out a negative, and it'd be negative bracket 2x squared plus 15, but I'm just going to leave it like that. And then that denominator is 3 root x squared plus 5. So that is the final simplified answer, and there are no restrictions.